So here I've got a large beaker of cold water, and the first thing I'm going to do is light a candle, which I'm going to put just under one side of the beaker. Okay, so light that there. And then we're going to slide this just under a side like that. Okay. Now I've also got in here some potassium permanganate, and I'm going to drop just a little bit of that into the top of the water of the beaker. So we can see we've got some little trails of purple as the dye falls in. And what we should find, maybe we need to adjust this up a little bit to heat it. Is that the heat from the candle begins to set up a current in the water. So you should be able to see the purple rising up on the right hand side, and then it'll drift over to the left and sort of start to come down again and make a kind of cycle moving from round here up, over and down again. So as the candle is heating up the water on the right, it becomes, well, the particles sort of vibrate faster, they bounce off each other a bit more, that water becomes less dense and it begins to rise. And then as it gets towards the top, it cools back down again and moves closer back together again, and then sort of sinks back down again towards the bottom. And that's what we call a convection current. Just going to give you a bit of a closer look now if I take my camera out of the mount. So it's a bit tricky to see. That's a better view. Now of course as the dye begins to run out and spread throughout the water and diffuse, which you will have covered already, it becomes more difficult to see the currents, but you can still see there is a line coming off that crystal of the permanganate at the bottom there and being pushed up towards the top. See, there it is from the side.